All right, ladies and gentlemen, we're going to be talking about really how to graph, but not directly. First, we're going to be talking about how to have a parent graph and be able to move to the other. So we have a parent graph, meaning when we're done graphing the function highlighted in blue, right over here, when we're done graphing that, it should look similar to the one over here on the actual graph itself. Now I'm missing this, so let me add that onto there. I don't like missing that. Now we're going to try to fast forward, but what it would take is at least 3 points, but the more points the better. So in this case, we actually kind of want to do 5 points. So what this would be is the idea of substitution, just like we did on the last lesson. How I'd write that as the function as evaluated at -8. Different ways of saying it, but that's what we're doing this time. Let me actually color coordinate this again a little bit better. What I'm going to do is I'm going to go ahead and use, we'll do orange. All right, so we're doing -8, and the 4 times quantity 2 to the -8 is where we're at. Like we discussed before, that's really just 4 times 2 to the -8. So we move that 2 and keep the 8 as positive now. And 2 to the 8th is going to be 256, if I remember correctly. And no, hold on. Yeah, 256. I had to double check in my head, notes, and everywhere else. So if I divide both of those by 4, I end up getting 1/64, which was the answer we had up here. Now, instead of doing that for all 5 points, I'm going to fast forward here, and here we go. What we notice is if I followed all the same rules, my blue points at -8 here, my second point that I needed to graph is at -4, and I know these because of my x values. So green is at 0, that's just my origin, and I know that again because of the x values, and when I plugged in 1, that would have been right around here, 1. And when I plugged in 2, that would have been right here on this line, that would have been 2. I have all the points and the corresponding colors above it. Now, how we can compare it is really kind of shortcutted. We didn't have to graph it. I wanted to be able to show you that it really is the same graph. If I was able to, and I could do this perfectly, which I can't, we would find it's basically the same graph, except we need to notice that, let's pick the green at 0. If we went, our point here should be about 1, and our point here should be about 4. So what we've done is we've increased or stretched by a factor of 4, and that's important because comparing the original graph, if we rewrote g of x as 1 times 2 to the x, we would actually have the non-parent function or the current function of 4 times 2 to the x. So the only thing that's different is the coefficient. The coefficient in this case being 4 is the value of a. And what that tells us is if we have a parent function where b is greater than 1, and basically it's saying this right up here, anytime b, or our base, is greater than 1, whatever is being multiplied by 4, the coefficient of it, that's actually how much it's stretching all of our points from the parent function. And that's our comparison. The domain and range, well, the domain is all real numbers. That's because we can pick real numbers. We can pick any number between -infinity to +infinity, even decimals, fractions, and everything else, negatives and positives, plug it in and get a value for y. But there's something we gotta notice. If we were to zoom in, we actually never reach 0. Maybe we do. What I mean is when x is equal to 0, we would never actually touch. sorry, not when x, when y was equal to 0. Oh my goodness, why did my brain say x? I'm sitting there looking and going, that's not right. Okay, when y was equal to 0, we wouldn't find an x. There would be no x we can plug in to make y 0. We have what it is when x is 0. It's y. And so we have to remember that domain is our x values. So that means that range are our y values. And since we can never be 0, we would actually never be able to be below it either. Look, the graph goes along and curves down, but it never goes to the negative. So really what that means is y always has to be greater than 0.